Hello and welcome to the InfoQ podcast. My name is Wes Rice, VP of Technology for Section. I'm one of the co-hosts for the show. The InfoQ podcast is a weekly podcast with tech leaders in software. We draw heavily from our experience with speakers at a conference called QCon. In fact, QCon London is coming up March 2nd through 4th in Westminster. So if you're listening this before then, you can meet us and today's guests at the conference. Today on the podcast, we're talking to Luca Mezzalira, VP of Architecture for DAZN, where his work is centered around mobile, desktop, web, TV, set-top, and embedded devices. So he has a broad range of experience. In addition, he helps to run and manage the London JavaScript community. And today on the podcast, we're talking about micro front ends. A micro front end architecture is an approach to building front end applications kind of modeled after microservices. The idea is to split up your front end into a set of independent, deployable, loosely coupled applications. These applications can then be assembled together to create a single user-facing application. Sounds great, right? Well, when you start digging into it a bit more, things start to get a little bit more complicated. Luca and DAZN have worked through some of these challenges and deployed a micro front-end architecture for their app. And he's here today to talk a bit about that tech and their experiences. Luca, welcome to the podcast.
Thank you very much.
Before we jump too much into the podcast, why don't you tell me a bit about DAZN and the work that you all do?
Yes, so DAZN is an OTT platform that is streaming live sports and video on demand. And imagine something similar to Netflix, but for sports. And the complexity that we are dealing every day is the live events. Because the reality is when you have a VOD, like you're watching, Stranger Things, if tonight is not available, you can retry in 1 hour or retry in the next day or the next week. And yes, you are a bit pissed off, but it's fine. For live, it's completely different. We have like a massive amount of users that are coming at the same time or 5 minutes before the kickoff of a match or the beginning of a match all together in our platform. And we cannot really say, oh, sorry, we cannot manage this load. And our challenge basically is providing the seamless experience that you have with cable provider, but on a OTT platform, so streaming live events on web.
All right. So I've been out of front end for, a few years. And so I really wanted to do this podcast to get kind of caught up on a few things. But about last year, I guess, beginning of last year or so, there was this whole explosion on social media about micro front ends. But that wasn't kind of where it started. I remember in Tech Radar seeing it in like 2016. Why did it take off last year? What was the buzz last year with micro front ends?
I think Microfront last year reached the success on socials mainly because a lot of important people in the JavaScript community shared their concern around the practice. But in reality, a lot of organizations nowadays are using in production this technique and this architecture, mainly because they need to scale not only the backend with microservices like many are doing nowadays, but also the front-end part because it's becoming more rich and our users are expecting a better quality and more richness of their experience. And this is a good way that you can achieve that because in front-end, the complexity of scaling is not on the infrastructure side, but is on the people side. And I truly believe that solving this problem would allow us to provide better experiences for our users.
That was going to be my question. When you talk about scaling the front end, you're not talking about horizontally scaling like you would with the web front end. You're talking about scaling like the people that are working on it. So many people can all work on one thing and not step on each other, right?
That's correct. And to a certain extent, you may have with Microfrontends the possibility to have challenges on scaling horizontally when you assemble them on the server side. But that is a specific use case because vast majority of the time you can serve directly from a CDN. In the case of our company, for instance, our infrastructure for the Microfrontends system is basically an S3 bucket with the Cloudfront. So nothing too crazy, very simple. And all the hard job is made at compile time and during the CI part. When we build our artifacts, we also do a lot of work for optimizing the code for pre-render the page to inline the meaningful CSS and HTML and create a skeleton that allow to provide an immediate feedback to our users when they load the Microfrontend.
So on your web application, what do you use to kind of horizontally scale? What's your architecture look like?
So for the front-end part, we have a very basic one. So we have Cloudfront and an S3 bucket. And we are using also Lambda at the edge. That is allowing us to do quite a few interesting things like canary releases or redirecting the crawlers from search engines to the specific version of our website that is optimized for crawlers. And that's really it for the scalability of the front-end part. For the backend, we're using microservices.
Let's back up a second and talk, what is a micro front end? What is the concept? I talked about it borrows from the idea of microservices, but how does a front end borrow from the idea of microservices?
For answer this question, I can tell you a little bit more on how I arrived to use this architecture. And I remember clearly when I joined my company several years ago, one question that my CTO asked me was, bear in mind that every time that you are going to take a decision, you need to think that we are going to grow and we are going to grow fast. And therefore, all your decision has to take in consideration not only the technical part, but also the people part. And that's what I have done. At the beginning, the main challenge was on front end, how I can scale an application. And unfortunately, I didn't find many answering in the front end community. So therefore, what I did was looking at the successful architecture that scale people and infrastructure. And obviously, the first one that bubbled in my mind was the microservices. So obviously, I couldn't refer to the technical implementation of microservices, but what I did basically, I said, okay, perfect, but microservices are based on principles. So let's look at them and try to apply those principles to the front end and see where we go. And maybe something good could come out from here. And it's exactly what I have done. So the fact that you can have independent deployment, the fact that you try to encapsulate the logic inside of the specific microservice, and the fact that you're trying to, let's say, having parts that are completely decoupled, that are communicating together, and then patterns that you can reuse in microservices like orchestrator versus choreography and so on. To a certain extent, those kind of principles can be applicable on the front end too.
When we talk about microservices, one of the big things that was an enabler for microservices is things like containers, where we can deploy things and kind of have like all of its dependencies isolated there. And it became the whole domain of what it was working on is isolated to that particular service. How do you apply a concept like that to the front end?
That's a really good question. There are a few techniques that you can apply. Iframes is one that currently is leveraged by quite a few frameworks that are out there. For instance, SAP released an open source framework called Luigi that what it does is creating a set of iframes and they deploy their microfrontends directly there. Spotify on their desktop application, they use a similar thing. So I like to understand how the things are working. So what I have done one day is looking inside the desktop application that I downloaded, and you can easily discover that they have created several packages with an extension that is SPA. So if you rename that extension to zip, you can unzip the content and see that you have web technologies that are living together inside, let's say, a native application, and they are rendering inside iframes, and they are communicating through an even bus across the different microfrontends. For instance, those two, let's say, approaches were one successful and one not that much. In the case of Spotify, they moved away on the web application on using the same approach with iframes because it was providing for the end user too much to download and it was too complex. But for the desktop application, it makes a lot of sense because everything is already there and is downloaded with the package. In the case of SAP, although it works pretty well because it's a B2B application, iframes allows you to don't care about memory leaks because it's a sandbox at the end. So the moment that you load something different inside the iframe, you are able easily to release all the memory. So you don't have to do any memory management at all. And they have also the control in the B2B world of which kind of browser and which kind of device their application should work. And that is a huge advantage because maybe in that case, you don't have to be under 4 seconds for downloading on mobile devices. Maybe there you don't have to use Internet Explorer 11 or be compatible with these old browsers. But the reality is that they can create some constraints and live inside that because this is the nature of their business.
So let's talk specifically about DAZN. How did you all implement a micro front end architecture?
For us, when we started this journey, first and foremost, we found the research around having multiple microfrontends in the same view. But in reality, we decided to go with a different approach that is called upshell. And we sliced our single page application vertically. What does it mean is basically our artifact for a microfrontend is a single HTML page or a single page application. And the decision on working this way, there are several of them in reality, but it was based on analyzing how our users were engaging with our application. And on top of that, we wanted to create a seamless experience for the developers on working on single page application. Usually when you start to create and you have like multiple microfrontends in the same view, the risk is that you need to invest way more for creating a decent developer experience, and therefore investing in CLIs and investing in tools and anything that will allow you to test in isolation and also see the overall impact of your microfrontend inside the context that is going to be deployed. So now for us, we don't want to, let's say, prevent to embrace a new, tool or library just because we took a path. So what we want to do is having the same experience for creating a single page application or a single HTML page for a developer. That is basically what they are doing since then they started to work as front-end developers, and provide the possibility to take decisions inside their own business domain. Because the reality is that I work as a tech lead and I work as a developer. And often the decision that we made, a few months before or years ago, took over for the entire life cycle of the project. But in this case, with Microfrontends, you can really say, I can take a local decision, and decision makes sense for my domain and for Microfrontend only. And the fact that we slice vertically empower the team to decide which library they want to use, they decide which framework they want to use, they decide several things without affecting too much the performances of the application.
So in the build stage, it's actually producing just a simple, server-side rendered HTML. So each one of the vertically sliced applications then could have their own build process that produce that artifact. Is that accurate?
That's correct. So what we have done basically is using the Holy Trinity front-end development, so HTML, CSS, and JavaScript. And the final artifact for us, the entry point, is an HTML page. There are other school of thought where, for instance, another framework called Single SPA use JavaScript. But one thing that I really wanted to provide to our users was the possibility to not wait to download JavaScript or multiple JavaScript files before showing something. So at compile time during our CI, basically, we are doing server-side rendering, as you described, with inline CSS and everything. And we provide the skeleton of the page only if needed. Obviously, if we have a microfrontend that is pretty fast to load, it's not a problem. We don't have to. But for some microfrontends, we want to provide this experience so we can give immediately a feedback to the user. Meanwhile, the browser is downloading the rest of the files.
All right. So when I was kind of prepping for this podcast, one of the questions that I was going to ask goes back to my days when I was developing portlets. When I was developing portlets, we would get into this scenario where one team was developing an application in those days using something like Dojo, something like multiple versions of jQuery or YUI. And when you started to assemble all these portlets, we wound up having all of these different libraries that were on the page, all of these different things that were having to be downloaded. And we had massive downloads and we had conflicts and namespace problems, all kinds of things like that. It sounds like from the approach that DAZN took, that by kind of doing that rendering on the server and assembling it to the user, you're just delivering a SPA, a single page app. So you kind of bypass some of those problems, right?
That's correct. Our approach solve out of the box all those problems. There are other companies that has multiple microfrontends in the same view, and they solve this problem defining upfront which framework they want to use. For instance, on top of my head, I remember that Zalando, that is the fashion e-commerce, was quite pioneer in this field. And the interesting bit is that in the last release that they are working since last year of their framework called Interface Framework, they decided to use React for all their components. And basically, they still use the console microfrontends, but deciding upfront which, in this case, libraries they want to use for rendering the application. Being technology agnostic on the microfrontends is, in my opinion, very important. I think in DAZN, we can reach that very easily, and we have like some successful stories that we can share. In other cases, when you have multiple microfrontends in the same view, I think technically you can do that, but it doesn't mean that you have to do that. It's a bit limiting, but at the same time, what I discover quite surprisingly in DAZN, for instance, that you have the possibility to have this freedom, that you end up with what is called the paradox of choice. So you have all the possibilities of the world, but then you are following what the others are doing. That is not, I know, a technical answer. Potentially you can do different approaches and different implementations, but the reality is I believe that also on a single page application, technically speaking, you can have multiple frameworks, but you don't do that because it wouldn't make any sense. So why would you do that on Microfrontends just because it's there? I think a good use case when that could happen is when you are porting maybe a legacy application to new life and you create a new project on top of it. And in that case, maybe you have to live for a while with Microfrontends at the same time having the monolith application that is running with a different technology stack. So in that case, it makes sense having maybe multiple frameworks that are downloaded for a certain period of time during the transition. Because the cool thing of Microfrontends is that you can use the strangle pattern and provide immediate value for your company instead of doing a big bang release a month later when everything is ready.
So I get the part about, having these individual sections that are assembled and compiled. It sounds like you still, and I can see the organizational benefits on being able to have different teams working on these individual sections. It sounds like just like when a microservices environment, you've got teams that are maybe delivering individual services. It sounds like you still need like the framework team, the team that's kind of laying out the overall framework that each of these things are coming in. Is that accurate?
Yes. So the glue of all those microfrontends is what we call the bootstrap for us. That is an app shell at the end. So every time that you load our website, immediately you download our app shell, that is the bootstrap, and is there for the entire life cycle for the browser session that the user is performing on our platform. The bootstrap is responsible for routing between microfrontends, is responsible for the application startup, and is responsible for abstracting the input-output operations that the microfrontend should do, like storing or retrieving a JWT token for understanding if the user is still entitled to watch some content. And we do in this way mainly because our ecosystem for frontend is pretty complicated. When you have to deal with TVs and set-top boxes and consoles where the storage is not always a web storage, so you cannot rely always on a local storage, abstracting the way how you store the content, it means that our app shell is device aware, but all our microfrontends are not because they are relying on the APIs exposed by our bootstrap. And that is pretty powerful concept because it means that currently in DAZN we are targeting roughly 30 different platforms in different version, obviously, but we have from different Samsung devices, different LG devices, different Panasonic devices, consoles like PlayStation, the Xbox, and so on. And all of them has their peculiarity. It's very fragmented. That world is more or less like the mobile world in early 2000. And having this abstraction allows us to focus the business logic on the microfrontend in a way that could work in almost every platform. And then having the bootstrap that instead is device specific and aware and is integrating with the operating system.
And does that app shell provide the cross-cutting services that each of the micro front ends need?
Correct. So what it does is exposing an API on the zone window object, where basically it provides some API like lifecycle APIs. So when the microfrontend is fully loaded, when it's about to be unloaded, and the microfrontend is responsible to hook up on those callbacks and react to that. Because one challenge that we had to face was if we are not using iframes, like we are not doing, we had to find a way to mount our HTML content inside an HTML page. And that was a nice challenge. But in reality, if you think about that, HTML is just a specific schema of an XML. And therefore, what it means is that you can parse it and you can use it and append your nodes inside other nodes. So basically, what we're doing is parsing this HTML and then append the JavaScript, so the script tags or the CSS tags or the DOM tags inside the app shell. And when we want to unload, we basically remove all of them and we load another microfrontend and we reappend all the tags that are needed for loading the microfrontend. It's very simple, but in this case, you need to bear in mind that you need to be 100% sure that there is no listener or object that could clash between microfrontends.
Yeah, so that brings up the next question about CSS and JavaScript. Are you just using kind of standard CSS and namespacing techniques with JavaScript to be able to isolate for each one of those micro front ends?
The beauty of this approach is that you don't need that because there won't be a clash. Because the moment that you have one microfrontend loaded, you won't have any other microfrontend loaded at the same time. So you always have one microfrontend inside the app shell per time. And that allows us to have this flexibility that we don't have to deal with that. Other companies are prefixing their CSS in order to avoid the collision. And that is a pretty standard technique that you can use in several of the other things.
But wait a minute, I don't understand that. So you've got this app shell that loads, and how can there only be one micro front end in it at a time? You might have many that are loaded into that app shell at a time, right? Because you're displaying many different units on the page.
Not always. And that's where I think we need to shed some clarity here. So there are two approaches for microfrontends. A microfrontend could be, as I described what we are doing in the zone, a single page application on a single HTML page. And in our case, we map our applications or our microfrontends to the business domain. So we have like an authentication microfrontend, we have a landing page microfrontend, we have a my account microfrontend, we have a discovery microfrontend. Then there are other companies that in the same view, they are trying to split the complexity, but not following a pure DDD approach. So usually there are some examples on several websites online where you can see that there are some buttons that are considered owned by one team and another one.
You said vertically sliced. So when someone has control of a route of a particular page that's being loaded, that is one of your micro front ends. That is a team that owns that experience. Is that right?
Correct.
Okay. And then it's each individual route when you may be handing off and going to another team.
Yes.
Okay. So let's talk then about that. How did you decompose who owned these? How did you break up the teams? How did you structure this?
So what we have done in the zone at the beginning was identifying our business subdomains. So following DDD, the first thing was identifying our core domain, what is our supporting domains, and what are the generic domains. And for instance, all the authentication, payment, subscription management is what for us is a generic domain. So it doesn't provide any competitive advantage compared to Netflix, Amazon Prime, or any other service that you can think about. And that was very interesting because when we started to do this approach, we suddenly discover that we can map our organization following those, let's say, buckets. And what we have done is reorganizing our dev centers around those concepts. So we identified that we have some generic domains and we put all together frontend and backend in the same dev center. We identify some core domains that is basically what differentiate us and we put in another dev center and so on and so forth. So currently we have 4 dev centers. Each of them are working together and they have their own domains that allow them to work independently from the others and sharing their practices and techniques with other dev centers.
So the thing that comes to mind when you talk a bit about that is Conway's Law. Conway's Law, as everybody knows, is companies tend to design systems that follow their communication structure. So do you run into that inside of a single UI, or do you find that you have silos with individual teams and that there's space between them?
Yes. So trying to overcome the Conway's law was the main reason why we tried to have in the same dev center the same domain, because this allowed us to share practices in the other dev centers and avoid communication overhead or external dependencies. Because one of the frustrations many developers has in large organizations is the fact that maybe you have a core team or you have other external dependencies during your sprint and you cannot really provide the value that you would like to do, and you don't have even the freedom to provide this value for your company. So analyzing this, we were able to implement what they call the Inverse Conway Maneuver, that basically is stating that first you design the architecture and then you define the organization. And this is pretty powerful concept because if you think about that, now we are in a situation where the teams that are working on acquisition and retention are all on the same dev center. The communication overhead is minimum. They share practices on a weekly/monthly basis with the other dev centers. And there is still communication across dev centers, but is reduced to not for external dependency, but mainly for sharing what they have learned. And that speed up a lot the development of our microfrontends and the possibility to deploy in production without coordinating multiple dev centers.
You know, as you're talking, the thing that keeps coming to my mind is complexity. I get that you can unblock these teams to be able to move fast and be able to kind of deploy at their own intervals, to be able to use their own technologies and then assemble things together and deliver it. But we use a similar approach for one of the apps that we use. I don't know that I'd call it micro front ends, but every time I try to build this and work on it maybe in an offline mode in my own machine or something, the complexity wrapped around assembling this thing is huge. When you're using this type of approach, are you introducing just a huge amount of complexity?
That's a great question. I believe that, like for microservices, in microfrontends, you cannot avoid to invest on automation. I think you really need to think through the developer experience and how you can solve this problem. Because otherwise, you can blame the architecture, but in reality, you didn't implement correctly or you didn't invest in the right thing. Think about microservices when you don't have a decent automation in place. It's a mess because it's very complicated to get it right and testing. And maybe one team is implementing logging one way, another team is implementing logging another way, and they are storing different places. It's a real complex problem. So as you have to do on microservices, some investment on automation, I truly believe that you have to do in microfrontends. The nice thing of what we have done is because it's a single page application, in reality, our microfrontend, it's easier. So you basically respect the paradigm that the front-end developer is used to. If you have multiple microfrontends in the same view, although you need to make an investment. New Relic, for instance, shared in a talk that they released pretty recently, I think it was last November, their approach, and they did a massive investment on creating a developer experience that is pretty smooth, and the developers can test in isolation as well with the entire view together with different microfrontends. But that is something that you need to invest upfront and take in consideration, because otherwise you are going to fail, but not because the architecture is a bad architecture.
Yeah, makes sense. So let's talk a little bit about how much scope these teams talk about. So you talked a bit about you have business functions and then teams that own that function. And so like one page is loaded in the app loader at a time for the single page app. How far back does that development team own the process? Do they go all the way back to the data persistence, through the service, through the front end, the whole thing? How far back are these teams structured?
Okay, so each front-end team has its own GitHub repository. We provide with the SREs team and the developer experience team a bit of infrastructure, like we're using Drone.io for parallelizing our build and for leveraging Docker containers and their power, because we have a specific use case in this case. So each microfrontend for us as output produce a multitude of artifacts. So we have code that is dedicated for, I don't know, the Japanese version of authentication. We have the code that is dedicated for the German version or the Italian version, and so on and so forth. So every time that we build a microfrontend, for the developers, they can jump from one country to another one. But as an output, we will have a specific microfrontend that more or less has always the same code. But in the case of certain countries, we have some integration or SDKs that are completely different. So this is completely transparent for the developer because it's not owned by them, but they can decide how they want to build the microfrontend. And that's a pretty powerful thing, because what we have seen so far in the last 2 years is that different teams approach in different ways and they use different plugins, the build of their microfrontend. And we obviously provide some guardrails that they need to follow. So we provide some plugins for Rollup and some others for Webpack. But the reality and the fact that I really like about this is that the team started to use new tools or different approaches, and they feedback the front-end community. And other teams start to do the same. And they are the first that they are trying to improve the situation. So each team has the possibility to decide what is running inside Drone.io, but Drone.io and a few other practices are provided by the company.
Okay, but they are front end developers themselves. They're focused only on the front end. They don't go all the way back into the services.
No, currently we have some teams that are full stack, some others are not. And I explain why. There are some teams that are full stack because we can afford that. Mainly teams that are owning components, not microfrontend. So the difference for me is microfrontend represents a business domain, but component is for us, for instance, the video player or the sports data. So a component is used like you would use any other component on frontend, where you import the library and you embed inside the microfrontend. That's how it works. And in that case, yes, makes sense having a full stack team. But for Microfront, in our case, if we have like a full stack team, the problem is the guys that are developing the APIs would interact mainly and optimize the APIs for the people that are working the same team. But in reality, we have teams that spread across different dev centers that are doing the mobile version for iOS and Android in different technologies. We have TVs that are spread in two dev centers and so on and so forth. So it would be unfair for them that they don't have a say. So we try to make a fair process where we have front-end and back-end teams on certain areas.
Earlier, you were talking a bit about the content and how it's distributed. You have these SPAs by business function. They're assembled by a build process. And then how's it distributed from there? You said everything's stored in an S3 bucket?
Correct. So what we do is during the build process, we pre-render certain microfrontends. Some others, they have just an empty HTML with a few tags like the JavaScript one and the CSS one. We store them in an S3 bucket. We created a dashboard that allows us to deploy the microfrontends because that is one of the investment that we decide to have. And that allows us basically to say, okay, I want to deploy the authentication microfrontend. I want to deploy that for web, and I want to deploy in Switzerland only. And then we can roll back and we can deploy a specific version if we want directly from this dashboard. It's a very simple one, nothing too crazy, but that allows us to provide visibility for our support, the people that are working on the support and are the first tier of support for us, and also for our developers that they want to know in a specific country which version of Microfront is available.
But when you talk about a specific country, you're not talking about S3. So you have like your CDNs that are maybe have points of presence in Switzerland. So you're able to deploy to that particular POP. Is that what you're saying?
No, the POP is completely transparent for you. So the nice thing of what we are doing is in the production S3, we have like multiple folders where there is the CH folder that is for Switzerland, the D folder is.
Oh, okay.
So there we can deploy our microfrontend, and the app shell is responsible as first thing to understand, to do the startup procedure that basically is understanding where the user is requesting this content. So if the user is in Germany, we load the microfrontend specific for that country with all the code that is specific for that device.
How do you leverage the CDN?
Yes. So currently we are using Cloudfront. And the interesting bit of that, one challenge that was raised by our organization was we would like to de-risk your deployment because we cannot afford to have, releasing the discovery microfrontend that contains the catalog and the video player, that is the key part of our platform, and deploy to 100% of our users without knowing if there are bugs in productions. So can you come up with an idea to solve this problem? So we use Lambda at the edge on Cloudfront for doing canary releases for microfrontends. So basically every time that you hit DAZN.com, there is a Lambda at the edge that is triggered and has the logic to understanding which country the user is requesting and which browser. And there we are just saying we have a configuration file where we say, okay, 20% of the traffic in Internet Explorer should go to the old version and the rest should be on the new version. And we can tweak these parameters without deploying a new piece of infrastructure or redeploying the Lambda at the edge, because there is just a configuration that the Lambda at the edge is storing in his header when it starts, and then till the Lambda is alive, we'll keep as it is. And then when it dies and the new Lambda is spin up, they will fetch again this configuration file.
All right, so let's start to wrap up. In March, in just a few weeks, you're going to be doing a talk called Lessons from DAZN, Scaling Your Project with Micro Front Ends. Obviously, you're going to be talking about front ends, but can you tell us a bit more about what you're going to cover in the talk?
Yes, of course. In the talk, I would like to share the experience and the journey that we had in DAZN, explaining the challenges that we faced, how we overcome them, and also I would like to provide some tips on how to approach microfrontends. There are a lot of questions that I see out there and a lot of skeptical people on how to implement, for instance, design systems, or if it's better to use a monorepo or a multi-repo, stuff like that. All those common questions is basically what I'm trying to address during my talk.
Now, you talk about a decision framework in this talk as well, right?
Yes, I'm going to talk about the decision framework that basically are for cornerstones that I identify for defining a microfrontend architecture. If you take those decisions upfront, when you start a microfrontend application, you will be able to cascade all the other decisions that are not less important, but are derivable from those four pillars. Usually those pillars are composed by four things. You need to identify the microfrontend. You need to understand how you compose them. You need to understand how you route microfrontends and how they communicate together. When you identify those four things, that is the part that I would like to highlight during my talk, you will be able to create your microfrontend architecture without many hiccups.
Well, Luca, I'm looking forward to the talk, and thank you for joining us on the InfoQ podcast.
Thank you for having me.